it is written. So instead of writing this x is equal to y star 50 inside the loop, we can write at the begin outside the loop also. That means in the beginning we can define the variable y is and assign that variable with 5, and x is equal to y star 15. That means 5 star 15 for 75 we can directly do. We do not have to use that loop, or so it will be simpler. That means loop will not execute, so execution time will be less. So but if we put in the loop, and every time it will check, the loop will execute from 1 to less equal to 10. But in this case, if we modify the code, that means if we put the logic outside the loop, so the loop will not execute. So that will save the time. So that is one kind of the code motion. Next is the loop invariant method. In this, the computation inside the loop is avoided. That is also similar to the previous one. The computation will be done outside. In this case, in the loop, a is equal to I plus b by c. That means here main computation is b by c. This is a fraction. So this it is defined outside the loop, and in the loop only that they will just add the two variables I plus t. From I equal to 0, I less than 10, I plus plus the t expression, the t function, what is b by c, that will be done outside the loop, because if the whole thing is done inside the loop, it will be very long process. So and it will be execute several times for each and every step, each and every iteration the loop will execute. And so that's why the computation part will be done at the beginning, and then just simple addition that will be done in the loop. So this is called as the loop invariant method. That means computation inside the loop. Here the computation is calculating the b by c value, so that it will be done outside the loop. Next is the loop unrolling, which is the number of jumps and tests can be reduced by writing the code 2 times. Next, here DOG is written. DOG is wrong. It is DAG. It is a printing mistake. So DAG is the directed acyclic graph. So directed acyclic graph, it is a tool that depicts the structure of the basic block. As I told that basic blocks, it will be it has only entry and exit, and it will follow the sequence of steps. So those things will be represented by the directed acyclic graph. Graphically it should be represented. It is used to apply the transformation on the basic block. That means basic block can be represented with the help of directed acyclic graph, and it is constructed by the following method. Leaf nodes are labeled by variable or constant, and interior nodes store the operator values. That is also, you can say, on regular expression. You can compare this analogously. Regular expression of the grammar, it will be we represented in the form of parse tree graphically. So this is also one kind of tree where the leaf nodes are labeled by the variables or constant, interior nodes store the operator values. So there are some various application of the directed acyclic graph. Determines the common sub expressions, determine which names are used inside the block and computed outside the block, and determine which statements of the block could have the computed value outside the block. That means the common sub expression, it determines the common sub expression will be represented at one point, and the values and the names which are inside the block and computed outside the block. As I show the loop thing, the what portion will be computed inside the loop and what portion will be computed outside the loop, and the statements of the block would have the computed value outside the block. That means these 2 points, that is the strength reduction and the code movement, what we say. That means the code motion and the loop invariant method. And the computation part will be done outside the loop, and also we can do which is known as that third point, that which statements of the block would have their computed value outside the block. Third point is similar to the loop invariant method, where the computation will be done outside the loop, and in the loop we will execute the simple statement. And second point, they determine which names are used inside the block and compute outside the block. That means in the loop the logic we will execute outside the loop. And next is the p-fold optimization. P-fold optimization, this technique is applied to improve the performance of the target program by examining the short sequence of target instructions and replacing these techniques by shorter or faster space. So this is also the another kind of optimization where as we know that optimization is the best possible outcome. So how we can develop the code, the target program, develop the code and improve the performance by examining the short sequence of the target. That means how to keep the logic in very short. That means that's also associated with the loop invariant method, and that means in the loop if we execute it will take some more time, and if we put the logic outside the loop it will take less time and the instruction will be executed faster. So next is the these are the two methods for the p-fold optimization, that is the redundant instruction elimination. See the example, redundant load and stores can be eliminated. X is equal to y and y equal to x will be written as directly. X is equal unnecessary 2 point statements writing is not required because both are same. X is assigned to y and y is assigned to x, so we can directly write x is assigned to y. And next is the unreachable codes are eliminated. That is for example this if statement in this case is not required, so this printf statement is unreachable, so unnecessary, no point of writing this sum is equal to 0 and if sum, there is no logic inside the if statement, so we can redundantly, because this will increase the size of the code. So in fact, in short, how we can write the code and get the output, so that is the optimization process. So the flow control optimization is also similar. Unnecessary, using p-fold optimization, unnecessary jumps can be eliminated. So p-fold optimization is the best optimization where we can reduce the unnecessary instruction and generate the code. So all this is about this intermediate code generation, code optimization. So in this way the compiler syllabus.
So can you explain flow control optimization?
Which one? Sorry,
flow control optimization.
Yes, flow control,
sir.
Yes, the last point what you are saying, flow controller, it is already displayed. So this actually it will unnecessary jumps can be eliminated. That means if you see that example, go to x is assigned to go to y and y is assigned to, so directly we can write go to y, because go to x is assigned x is going to go to y and y is going to nothing, so directly we can write go to y and x is go to y. So unnecessary we cannot
Sir, I think x is not necessary here.
Yes,
second go to y and this x is not necessary.
Yes, you are right. That's why so this x is not necessary, so we no need to write that statement, we can directly go to y. So that is the optimization process. That means the logic we will get the same output if we write this lengthy process, go to x is to go to y and y, but if we directly go to y then also we will get the same output, so it will be better to write directly go to y, so x is not required. So that and so that is optimized part, optimize, best solution we are getting. Actually all these things are these are the scenario what is happening while executing this compiler. In fact, whole thing is the scenario what is going to happen when we execute the code. You have written, very languages, many languages I think you have learned, Java, C, C++, all those things, only syntax are different, but all those cases the compiler is doing and the source code is converted to the target language in the machine language, and this is the scenario behind this. And today what we have discussed this loop invariant method, loop rolling, this will help you to develop the code and how short you can write the code in order to get the output, which will save the memory allocation as well as the computational time. So all these things can be done, you learn from this compilation process. So anything you want to ask, you can ask.
No, sir. Sir, please send the PDF in.
Yes, PDF I will going to send, and I'm showing you some model question, that also I will give it to you.
Yes, sir. It will be definitely helpful for
Yes,
us.
let me show you once. I will send this PDF and also those model questions. So these there are around 96 questions are there. You can and I have given all the answers also. So you can see this. You try to solve this question and check your answers with the help of answer sheet. Answer sheet is given at the end.
Okay, sir. Thank you, sir.
So you practice, and if you have any doubt, you can. So I have my gate class for the compiler lecture is finished. 3 classes have been over. So
Yes.
till now, if you have any doubt, you try to solve these questions. If you have any doubt, you can come to my chamber. My room number is 213. Anytime you can come, and if you have any doubt, you can ask me.
Yes, sir. Thank you, sir.
Okay, okay. So then let me close the session then. I'm closing it.
Yes, sir.
Okay, thank you.